The ocean stretches before us, a canvas of deep blues and greens shimmering under the tropical sun. It appears calm, almost serene. Yet beneath this tranquil surface, a dramatic transformation is about to begin. The stage is set for one of nature's most awe-inspiring spectacles, the birth of a cyclone. The temperature of the ocean surface is crucial. It must be exceptionally warm, exceeding 26 degrees Celsius, for a cyclone to form. This warmth acts as the fuel, the lifeblood, of the impending storm. Imagine the ocean as a colossal solar panel, absorbing vast amounts of heat from the sun's rays. This warmth doesn't just sit on the surface, it penetrates the upper layer of the ocean, creating a deep reservoir of energy. This reservoir is the key. It's the wellspring from which the cyclone will draw its ferocious power. As we watch, the ocean seems to hold its breath, a giant about to stir. The sun continues its relentless heating, and an invisible transformation begins. Water molecules on the surface gain energy, becoming so excited that they break free from their liquid bonds. This process, known as evaporation, sees the ocean seemingly vanish into the atmosphere, transforming into an invisible vapor. We can't see this vapor, but we can feel the increasing humidity in the air, a telltale sign of the ocean's contribution to the sky above. As the warm, moist air rises, it cools, and the invisible vapor condenses. Tiny water droplets form, clinging to microscopic particles in the air. These droplets, too small to be seen individually, gather in their trillions, forming the majestic clouds we see billowing upwards. The sky, once clear, now teems with towering cumulus clouds, their bases dark with moisture, their tops a brilliant white in the sunlight. The ocean's vapor has become a canvas for the sky, a breathtaking display of nature's artistry. The rising air, laden with moisture, acts like a giant chimney, drawing more and more moisture from the ocean below. As the water vapor condenses back into liquid droplets, it releases even more heat, fueling the process further. This heat, known as latent heat, further warms the surrounding air, causing it to become less dense and rise even faster, accelerating the cycle. The air pressure at the surface drops, creating an area of low pressure. Nature seeks balance, and this imbalance sets the stage for something powerful. Air from the surrounding areas where the pressure is higher rushes in to fill this void, creating strong, inflowing currents. This continuous cycle of rising warm air and inflowing cooler air creates a powerful rotating column of wind, a nascent storm. The rotation, however, is not random. It follows a specific pattern. It is dictated by a force we cannot see but which governs the movement of all fluids on a rotating Earth, the Coriolis effect, a crucial player in storm dynamics. This invisible force will now sculpt the storm, giving it its characteristic spin, shaping its structure and intensity. The ocean, once a source of calm, is now a cauldron of energy, its vast reserves feeding the burgeoning storm, turning tranquility into turmoil. The Earth's rotation, while seemingly imperceptible to us on the surface, plays a crucial role in shaping the storm's rotation. This constant spinning motion is what sets the stage for the dynamic weather patterns we experience. This force, known as the Coriolis effect, causes the inflowing air to curve as it travels across the Earth's surface. It's a fundamental aspect of meteorology that influences everything from ocean currents to wind patterns. In the northern hemisphere, the air curves to the right, creating a clockwise rotation in weather systems, while in the southern hemisphere it curves to the left, resulting in a counterclockwise rotation. This curvature is not a result of some mystical force, but a simple consequence of the Earth's rotation beneath the moving air masses. It's a fascinating interplay of physics and planetary motion. Imagine standing at the North Pole and throwing a ball towards the equator. This thought experiment helps illustrate the Coriolis effect in a more tangible way. To you, the ball would appear to travel in a straight line, unaffected by any external forces. However, to an observer in space, the ball's path would appear to curve to the right because the Earth is rotating underneath it. This curved path is a direct result of the Coriolis effect. This same principle applies to the air rushing towards the low-pressure center of the developing cyclone. The air doesn't move in a straight line but follows a curved path. The Coriolis effect, though invisible, is the unseen hand that guides the storm's spin, shaping its structure and intensity, transforming it from a chaotic mass of wind and rain into a tightly wound spiral of immense power. This transformation is a testament to the incredible forces at play in our atmosphere, driven by the Earth's rotation. Section 5. Anatomy of a tempest. The cyclone now begins to take on its characteristic shape, a well-defined structure with distinct regions of intensity. At the very center lies the eye, a zone of eerie calm. Here, the winds are light, the skies often clear, and the sea surface may be surprisingly calm. The eye is surrounded by the eye wall, the most dangerous part of the storm. Here, towering thunderstorms rage, generating the most violent winds and torrential rainfall. Extending outwards from the eye wall are spiral bands of thunderstorms known as rain bands. These rain bands can stretch for hundreds of kilometers, carrying heavy rain, strong winds, and even tornadoes far from the storm's center. The cyclone, now a fully formed entity, is a marvel of nature's power and complexity. It is a giant heat engine, drawing energy from the warm ocean and converting it into wind and rain, a swirling vortex of destruction and beauty. Section 6. Fury Unleashed. Let us now witness the awe-inspiring power of a cyclone at its peak. As the cyclone gathers strength, its winds howl with a deafening roar. The ocean churns violently, whipped into a frenzy by the sheer force of the wind. Waves towering tens of meters high crash onto coastlines, swallowing entire beaches in an instant. The rain falls in sheets, not drops, flooding streets and fields, turning rivers into raging torrents. The cyclone, a force of nature unleashed, reminds us of the raw power that shapes our planet. Section 7. Guided by the winds of the world. Cyclones do not wander aimlessly across the ocean. Their paths are influenced by global wind patterns, steering them like leaves in a stream. These patterns, driven by the uneven heating of the Earth's surface, act as invisible highways, guiding the cyclones on their journeys. In the tropics, where most cyclones form, the trade winds blow consistently from east to west, pushing the storms towards the western edges of ocean basins. As cyclones move poleward, they may encounter the westerly winds, which blow from west to east in the middle latitudes. These winds can deflect the cyclones, causing them to curve back towards the east or recurve out to sea. The interaction between a cyclone and these larger-scale wind patterns determines its path, influencing where it will make landfall and unleash its fury. Section 8. The inevitable wane. However, even the most powerful cyclones cannot escape the inevitable. As they move over cooler water or over land, they lose access to the warm, moist air that fuels their intensity. Cut off from their energy source, they begin to weaken. The once towering thunderstorms within the eye wall dissipate, and the winds gradually subside. The cyclone, starved of its fuel, begins to unravel. Over land, the friction from the Earth's surface further weakens the storm, slowing its winds and reducing its rainfall. Gradually, the once mighty cyclone transitions into a less organized area of low pressure, its remnants drifting across the landscape, bringing much-needed rainfall to some areas but leaving a trail of destruction in its wake. Yet, even in its demise, the cyclone plays a crucial role in the Earth's climate system, redistributing heat and moisture from the tropics towards the poles. Section 9. Nature's patient renewal. In the aftermath of a cyclone, the landscape may appear devastated, a scene of utter chaos and destruction. Trees lie uprooted, buildings reduced to rubble, and coastlines reshaped by the storm's fury. The sheer force of nature leaves a lasting mark on the environment. Yet beneath the surface of destruction, the remarkable resilience of nature is already at work. Life finds a way to persist, even in the harshest conditions. Plants begin to sprout anew, their roots seeking nourishment in the freshly watered soil. The cycle of life continues, undeterred by the storm's wrath. Animals emerge from their shelters, cautiously exploring the altered landscape. They adapt to the new environment, finding new paths and homes. The ocean, too, begins to heal. The once turbulent waters start to calm, signaling the beginning of recovery. The churning waves subside, and the marine ecosystem slowly recovers from the storm's impact. Marine life begins to return, restoring balance to the underwater world. Coral reefs, though fragile, have an astonishing ability to regenerate, their broken branches providing the foundation for new growth. This regeneration is a testament to nature's resilience. Fish and other marine creatures return to their familiar haunts, repopulating the waters. The underwater community rebuilds itself, piece by piece. The cycle of destruction and renewal, as old as time itself, reminds us that nature possesses an extraordinary capacity to heal, to adapt, and to thrive in the face of adversity. This cycle is a powerful reminder of the resilience inherent in all living things. The cyclone, though a force of immense power, is but a fleeting moment in the grand tapestry of life on Earth. Nature's patient renewal is a testament to the enduring strength and beauty of our planet.